I've come up with new algorithm, multistage graph. This algorithm can be solved using dynamic programming. Let's start the procedure. In multistage graph, we are given with the directed weighted graph. The graph is divided into stages. Let's understand this. Given with the source S as vertex 1 and the destination T as vertex 12. So I have to send the information from source vertex 1 to vertex 12. So how to send the information? So this graph is divided into multiple stages. What are these stages? The stages are, I have divided these stages into 5 stages. So V1 will be the stage 1 where it is a source. So in V2 is a stage 2. So in this stage 2, I have divided the vertices into stage 2, 2, 3, 4 and 5. These are all the vertices which comes in stage 2. So these are the vertices which are in stage 2. So next the vertices which are in stage 3 are 6, 7 and 8. So these are the vertices in stage 3. So V3 is represented for stage 3. V4 is represented for stage 4, which comes 9, 10 and 11. V4 is for stage 4. Finally we have V5 as the stage 5. So final destination is V5. Movement of the information from the source 1 will go to stage 2, whichever vertex in the stage 2, it will be reaching stage 2. From stage 2 it will reach stage 3. From stage 3 it will reach stage 4. From stage 4 it will reach the final stages. So for this, each iteration we will be choosing one from the one stage and we will iterate from that. Let's understand the procedure for multi-stage graph. Source is 1, vertex 1 and destination is vertex 12, but I am beginning from vertex 12, the destination. From destination I am starting. So 12 is having the vertices 9, 10 and 11, which are reachable from 9, 10 and 11. So to represent this, I am representing this in the cost. So cost 4, what is this 4? 4 is at the level 4 is level, and 9 is what? Individual vertices. So cost of 4 level, 9 vertex. What is the cost? What is the weight? Weight is 4. So weight is 4. So I am going to visit vertex 9. From 9 I am going to visit the vertex destination vertex 12 and its cost is 4. So this is the representation for this one. So next, from vertex 10, this vertex 10 is at the level 4, so 4, and the present vertex 10. So from 10 I can reach the destination 12 with the cost 2. So this is weight. So from 11, vertex 11 is at the level 4, vertex 11, I can reach the cost destination 12 at the weight 5. So this is the representation for the level 4. We got the solution from stage 4. So next we'll be seeing this from stage 3. So cost from stage 3 or level 3, stage 3, vertex 6. So vertex 6, so I have two vertices which is going to vertex 9 and vertex 10. So I have to choose among them which is the best one. So I have to choose which is minimum. So for this I have written here minimum of 6. What is the 6? So the cost from vertex 6 to reach vertex 9 is 6. So 6 plus the cost of 4 to 9. So this is 4 to 9 is 4. Cost of 4 to 9. So 9 we already know that it is going from 9 to 12 and its cost is 4. So this is 6 plus cost of 4 to 9. This is 4 is level. Please remember, don't misunderstand this. 4 is level. So cost from vertex 3 to 6 is 6 plus cost of 4 9. Next, plus 5 plus cost of 4 10. 4 is vertex 10. So this is this one. So I have represented this. So the weight we have got is 6 plus 4, that is cost of 4 9 we have got from this, and 5 plus 2, the cost of 2. So this is, amongst this minimum is 7. So this 7 we got. The path which is achieved here is, it is something like this. It is the minimum cost for 3 6. 3 is the vertex stage, 3 is the stage and 6 is the present vertex. So this one. So amongst these two paths I have got the path 6 10 12 as the ideal path. So 6 to 10, 10 to 12, I got this path as the ideal route for the vertex 6. Now we'll see it for vertex 7. So vertex 7. So vertex 7 is represented something like this. 3 is the level and 7 is the path. 3 is the level and 7 is the vertex, present vertex. So this, even this 7 is having two vertices, which is going through 9 and which is going through 10. So among this, which vertex is going to lead us to the minimum path? The path is the min of 4. What is this 4? From 7 to reach 9 is 4. 4 plus cost of 4 to 9 is what? It is 4. So cost of 4 9 is 4, and present cost from 7 to 9 is 4, so it is 8. Next, minimum of from cost 7 to 10 is 3 plus the cost of 410 is 2, so this is 2. So amongst these two, 8 and 5, we got 5 as the minimum cost. The route goes something like this. It is going from 7 to 10 to 12. So this is the route. Among the route 7, 9 and 12, we are getting the better route 7, 10 and 12. Next we'll see with respect to vertex 8. This is at stage 3 and vertex 8. So this is cost 3, 8. 3 is level and 8 is the present vertex. So it is minimum. So even 8 is having two vertices. It is going from 8 to 10, 10 to 12, and the other one is going from 8 to 11, 11 to 12. So I have two vertices. It may go from this or it may go from this. So amongst these two, which one is the better one? We'll see it by using multistage graph algorithm. So in this 5 is what? 5 is the present state. It is 8 to 5 is 8 to 10 is 5. So plus the cost of 10. So from 10 to 12 we know that the cost is 2. So this is 2. Next, 8 to 11. 8 to 11 is 6. 6 is here plus the cost of 11. Cost of 11 we know from this here previous findings. So cost of 11 is 5. So 5 plus 2 is 7, which is better than 6 plus 5, which is 11. So 7 we have chosen. The path which has been chosen from here is from 8 to 10, 10 to 2. 10 to 12. So cost is 7. So we got 7. So these are the data which has been found. So what I'll do is I will erase out the calculation part and only retain the values in the next level. So in this level I have represented only the values which we got from the stage 3. So next we'll find out how to proceed with the stage 2. We have got the values from the stage 4, we have got the values from the stage 3. Now we'll see how to find the procedure for the stage 2. So procedure for the stage 2. In stage 2 we have vertex 2, vertex 3, vertex 4 and vertex 5. So we have to find out the values, minimum values for all these vertices. So cost of 2, 2. 2 is, first one is level 2 and vertex 2. So vertex 2, this vertex 2 is having 3 vertices. It is going from 2 to 6, 2 to 7 and 2 to 8. So 3 vertices. So the cost will be represented in the form of 3 minimum paths. So from 3 minimum paths, which one is the greatest cheapest path? So 4, 2 to 6 is cost 4, 2 to 6 is 4, plus the cost from 6, we have found the cost from 6 is 7. So in the previous table, please see the pointer, the cost of finding the weight from 6 is 7. So this is what we are going to use it. So from 2 to 6 the cost is 4, so we have represented the cost as 4. Then from 6 to 9, from this route we already know that the cost is 7, so we have represented this as 7. So next 2 to 7, 2 to 7 is 2, so 2 to 7 is 2, so we have represented this cost as 2, plus 7 to 12, this route we know that it is 5, so we represented 5. So next, after this 2 to 8, 2 to 8 is 1, so we know that the cost of 2 to 8 is 1, so 1 is here, so we represented it as 1, plus the cost from 8 to the destination is 7, so this is 7, So we represented this. So amongst 4 plus 7 11, 2 plus 5 7, 1 plus 7 8. So we get the cheapest route as 7, so we represented this as 7. So the path which we achieved by the stage 2 vertex 2 is 2. So I'll clear out this. So this is 2 to 7, 2 to 7, 7 to 10, 10 to 12. So this is the final path we got from vertex 2. So we'll see from vertex 3. So it is at stage 2 vertex 3. So this one we are going to find out. So for vertex 2 we are going to stage 2 vertex 3 we are finding. So cost of 2 comma 3 is equals to, so this vertex is having two vertices, so sorry, two edges, 3 to 6, 3 to 7. So amongst these two, which one is the lowest cost? So lowest cost we'll find out. 3 to 6 we are going to find its cost is 2 plus the cost of 6 to reach the destination, 3 to 6, which has been found from here, it is 7. So 2 plus 7 is 9. Then the cost of 3 to 7 is 7. So it is hidden behind the marking, so I'll erase this. The cost is 7 plus, this is 7 plus the cost to reach the destination from 7 to 12, it is 5. So amongst these two, 2 plus 7 is 9, 7 plus 5 is 12. So amongst these two we are going to get the lowest cost as 9. So I have marked this as yellow color. So path is 3 to 6, 6 to 10, 10 to 12. So the path goes something like this: 3 to 6, 6 to 10, 10 to 12. This is the lowest cost path which we are going to achieve from the vertex 3 or in the stage 2. So next we are going to see for vertex 4. So cost of stage 2 vertex 4, in this we are having only one edge from 4 to 8. We don't have any other edges following from 4 to 8. So the procedure is very simple. Only for this edge we have to calculate. There will not be any minimum cost. Only whatever the cost we have, it will be the perfect cost. So 11 is the weight from 4 to 8. So 11 plus the cost to reach 8, we already have the value 3 to 8 as 7. So 8 to 12 is 7. So 11 plus 7 is 18. So this is the path from 4 to 8, 8 to 10, 10 to 12, which we found from this procedure. So next we are going to see the cost from vertex 5. So from vertex 5 in the stage 2, it is 2 comma 5. 2 is the stage and 5 is the present vertex. So from 5 we again have two routes, 5 to 7, 5 to 8. So which one is the cheapest part? So 5 to 7 we have the edge as 11. So 5 to 7 is 11 plus 7 to 12 we have cost of 7. So 11 plus 5 is the edge from 5 to 12. Then which is going through 7. Then we have 5 to 8. 5 to 8 is 8 again, 8. So 8 plus the cost of 3 comma 8, 3 comma 8 is 7. So it is 11 plus 5 in the previous one and 8 plus 7 in the present one. So 8 plus 7 is 15. So the cost which we are getting, the path which we are getting is something like this: 5 to 8, 8 to 10, 10 to 12. So this is the cost path which we get from the present fifth vertex. We have found out the cost from stage 4, stage 3, and now we have come to stage 2. We have finished also stage 2. So I have deleted all the procedure for doing this. So I have retained only the values which are which are correct, which is showing the minimum path. So I have retained those. Now we'll calculate from the stage 1. So cost stage 1 and vertex 1. So it is from stage 1 we can see that from vertex 1 we can see that there are 4 vertices. So from 1 to 2, 1 to 3, 1 to 3, 1 to 3, 1 to 4 and 1 to 5. So these are the vertices which I have to check for the minimum cost. So first one, 1 to 2. 1 to 2 is 9. So 9 plus the cost 2 comma 2, it is 7. So it is 9 plus 7. Next 1 to 3. 1 to 3 is 7. 7 plus the cost to reach the destination from cost to 3 we can get from stage 2. So 9. Next cost cost from 1 to 3, 1 to 4, it is 3. 1 to 4 is 3 plus the cost to reach the destination 2 to 4. Next 2 to 4. Next after this 1 to 5, we have 2. The cost from 5 is here, the cost 2 to 5. So we have 9 plus 7 plus 7 plus 9, 3 plus 18, 2 plus 15. So amongst these, 9 plus 7 is the lowest cost, and it is going to get us 16 as a result. So the route which goes from here is something like this. The route is which is going from 1 to 2, 2 to 7, 7 to 10, 10 to 12. So this is the route which we achieve, and this has been marked with the red. So the path which we get is 1 to 2, 2 to 7, 7 to 10, and 10 to 12, and the cost which we are getting is 16. So at each stage we are finding one vertex which is having the lowest cost, and from that we are going to find out the exact route to the destination. So this is how we are working in stages. So this is multi-stage graph with respect to dynamic programming. Thank you.